Hello everyone, welcome to our channel. Here we are going to learn some of the topics used in competitive programming. We are going to learn some of the advanced data structure algorithm used in competitive programming. So what I have thought that I will make a full playlist of the topics provided in the CP algorithm site. I will make the video one by one of these topics. So what will be the agenda for a topic? So first we will exp- first we will see the basics of the topics, some theory about the topic, then we will see the coding of the topic, and then in another video we will see some of the applications of the topic. So what are the various applications of the topics we are learning and where it can be used. Okay, so it is indeed the one of the best site I used to refer for competitive programming stuff. It is one of the best site for competitive programming I have ever found. So what so today we will learn about binary exponentiation. So let's go dive deep into it. I will put the link in the description box for this website. So what is binary exponentiation? So binary exponentiation basically means exponentiation by squaring. It is a trick which allows you to calculate a की power n using only log n steps, log n multiplication instead of O(n) multiplications required in the naive approach. Okay, so for example, you have to calculate a की power b. For example, you have to calculate a की power n. Let's say you have to calculate 2 की power 8. So what will you generally do? 2 into 2 into 2 dash 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 up to 8 times. 8 times that you will do, and it so what will be the approach for this? You will make a loop from I equal to 1 to 8, and you will multiply the result into equal a for 8 times. So what will be the time complexity of this approach? So here n equal to 8, so it will be O of n. So it is a so let's say you have to calculate, for example, 2 की power 1 in 9, 2 की power 1 billion. So what will be, so it is, so we can't calculate it because in the online compiler or online jet we are used to, we only can use up to 10 to the power 8 operations, and it is a very huge number to calculate 2 की power like something this very big. So we can't go off an approach for this. So the binary exponentiation is a very good trick, very good algorithm for calculating a की power n using only log n multiplications. Okay, so what is the basic theory, or what you can say, the proof for it? Proof, not proof. So for example, you have to calculate a की power b plus c. So what it can be written as a की power b into a की power c. Okay, so for example, if you have to calculate 2 की power 8, you can divide it into 2 की power 4 into 2 की power 4. For example, it is the basic expression for this algorithm. For example, you have to calculate a की power 2b. So for it is a की power b into a की power b or a की power b का square. So if you know a की power b, so calculating the square is only one operation. So you have to so let's say you have to calculate a की power 2b. So for what you will do, a into a into a into a. So let's say it is b times, and you have to move b times more for 2b, a into a into a into a. So you can save these much operations by using this a की power b का square. You can just take this number and square it, then you will reach to this number. So it is basically this fundamental, or on this theory it works. So what is the basic of the binary exponentiation is that we can split the n. For example, we can split the n in into binary representation. For example, if we have to calculate 2 की power 10, 2 की power 10, and here 10. So what is the binary representation of 10 here? 1 0 1 0. So you can split it as 8 plus 2, 8 plus 2. So if you somehow get to know 2 की power 8 and 2 की power 2, then you can directly multiply it and can reach 2 की power 10. Okay, this is the basic thing. So for example, here it is tell this you have to if you have to find naively you have to perform like this. However, it is not practical for large n. So it is the thing that I have told you. So for example, you have to calculate 3 power 13. 13 can be represented as 1101 equal to 3 power 8 into 3 power 4 into 3 power 1. So how the time complexity of this algorithm is log n. So you can see that there are only log n digits in the binary representation of any number. There are only log n digits, log n plus 1 digit. So you have to perform only log n multiplications, as there are 3 power 8 into 3 power 4 into 3 power 1. So you have to perform only log n multiplications. So its time complexity is log n. So it is a fast way to compute this. For example, you have to calculate 3 power this 8 4 3 1. So what is 3 power 1? 3. What is 3 की power 2? 3 की power 1 का square, it is 9. 3 की power 4 is 3 की power 2 का square. 3 की power 8 is 3 की power 4 का square. So as you can see, as you can see the pattern here, like this. 3 की power 2 equal to 3 की power 1 का square. 3 की power 2 can be represented as 3 की power 1 plus 1 equal to 3 की power 1 into 3 की power 1. It is 3 की power 1 का square. What is 3 की power 4? 3 की power 4 can be represented as 3 की power 2 into 3 की power 2. It is indeed the 3 की power 2 का square. So you can see that like this: 2 4 6 2 4 8 16 and 32. It is, so you have to find, for example, any number a की power 4. So it is indeed the a की power 2 into a की power 2 or a की power 2 का square. So you just have to square it. That's only, and you will eventually reach to your goal. Okay, so this is the basic funda of this. So for example, we will only multiply those number which are set in which have set bits in the binary representation. For example, 13, we have to calculate 3 power 4, then 3 power 8. But we, as you can see in this, we doesn't have 3 power 2, so we skip 3 power 2 and just multiply 3 power 8, 3 power 2 and 3 power 1, and we will eventually get to our answer and of log n steps. It is the recursive relation of this. So you have to calculate a की power n. If n is 0 greater than 0 and n is even, so we will return a की power n by 2 का square. And if it is n equals 0, then 1, because a की power 0 is always 1. And if it is odd, then a की power n by 2 dot a. Okay, so it is the recursive code of it, and it is the iterative code. So let's see the recursive code of it. So first, let's see the recursive dry run of a function. For example, you have to calculate the power of 2 की power 14. Okay, so what you will do, let's first see the code. So here it is provided that if b equal 0, for example here b is are 14 and a is are 2, 0, then we will return 1. 1 minute. We will return 1, and if it is not the case, then we will store the result of a की power b by 2. And if b is odd, then we will return res into a, means this relation res का square dot a. Result is this n by 2 का square and minus 1 by 2 का square. It is basically the floor of it, and in the calculation it is just b by 2. It will, you have to only get the integer part, and if it is even, then you have to just square it. Okay, so let's see the dry run of it. It is a recursive approach. Power of 2 to the power 14. So what it will call, it is b is not 0 here, it is 14. So what we will do, we will call, let's see what we will call. We will store the result in to store the a की power b by 2 in result. Okay, so here it will be called power of 2 की power 7. Okay, what it is not equal to 0 here also, so it will call power of 2 की power 3. It will call power of 2 की power 1, and it will call power of 2 की power 0, and these all are stored in some variable, that is result, as you can see. So here it is 0, so what it will return? It will return 1. It will return here 1. Okay, so so 1 is returned here. So if you can see, if b is odd, then we will return rest into rest, the return part, and into a, and if it is not, we will just square. Okay, so here it is, as you can see, the b is 1 and it is odd, so what will we do? The result is 1 here, so 1 into 1 into 2, it is indeed the 2, and 2 power 1 is 2. Here it is 3, it will return 2 here, it is 3. So what you will do? 2 into 2, it is the square of this, 2 into 2, and into 2 for this part, rest into a, for this part, rest into a. Okay, so it is indeed the 8. So 2 की power 3 is 8. Okay, so it will return here 8. It will return here 8. So what is 2? It is odd. So 8 into 8 into 2, it is this. 8 into 8 into 8 is 64. 64 into 2 is 128. So it will return 128 here. So it is 2 to the power 14, and 2 to the power 14 is, it is even. So what we will do? 128 into 128, and it is indeed the answer of power of 2 to the power 14. So as you can see, these are only the calls made. So how many calls are made? There are only 1, 2, 3, 4, and 5 calls are made, as 2 to the power 14 can be represented as 1, 1, 0, and 0. It is, so log n plus 1 calls are, log n plus 1 calls are made here, as you can see. So the time complexity of this approach will be log n. So here we will get our answer. Okay, let's see some coding of it, recursive coding, then we will go in iterative one. So it is a template of mine. So I am, so let's tell something about, so I should tell something about me. I am Naman Dwivedi. I am currently a student at Kite Group of Institutions, Ghaziabad. I have reached expert at Code Forces and 4-star on CodeChef. Okay, and so let's make a function which will return a long, and we will name as binpow. Binary exponentiation. Let's say binary exp. It will receive a long int a and long n. Okay. So what we have written, if n equals 0, then what return 1. Return 1. Else, if it is not the case, then we will store a result of bin expo binary exponentiation a comma n by 2. Okay. 1 minute. Sorry. So let's start from here. So we will store the result of this, and the result when the result will be returned, so what we will check, if our n will be odd, if n not to equal 1. So what we will do, we will return basically rest into a, else if it is even, return rest into rest, and that is indeed the answer. Okay, so let's check if it is working true. Let's take here one, what will have to calculate a power 14 will give, so lln comma lla comma lln cn a cn, we have to calculate the answer equal to bin expo a comma n. and print the answer. So let's see if it is giving the correct answer or not. What it is? L A comma L N. Okay, sorry mistake. Then let's see if the answer given to us is correct or not. It is 16384. Let's use the calculator. What we have calculated 128 into 128. 128 into 128. And it is indeed 16384 as you can see. So it is a recursive code. And now see the iterative one. Iterative one it indeed the fast as in recursion there is a recursive overhead. So the second approach accomplishes the same task without recursion. It computes the parts in a loop and multiplies the ones with the corresponding set bit in n. Although complexity is same, but approach is faster in practice because there is overhead of the recursive calls in the recursive approach. Okay. So what this function takes? This function also takes a and b. So what we are doing here, in recursive approach, we are taking n and we are going till 0, and we are then in return we are calculating the result. It is in the recursive approach. Okay, so means any power a ki power 0 equal to 1. So in the iterative approach we will start from 1, means a ki power 0 we will start from 1 and we will go till a ki power n, now in a loop. Okay, so it is the difference between recursive and iterative approach. So let's see the dry run of it also. First see the code that you can have better understanding. So here we will initialize the result as 1, and while b is greater than 0, because here we have to divide the b by 2 as you can see. So while the b is greater than 0 and if b is odd, so you have to what do you have to res equal to res into a, and a equal to a into a you have to do always, and then b divided by 2. Let's say it in the dry run and you will have a better understanding. So we have to calculate 2 ki power 14 here. So what we will do, power of 2 ki power 14. So here the result is initially the result is 1. Okay, and while b is greater than 0, b is are greater than 0 as it is 14. And if b is odd, no, it is not odd. It is not currently odd. So what we will do here, it is even. So what we will do, we will multiply result into result. So 1 into 1 equal to 1. Okay, so and we will divide the b by 2. So now it will become 2 ki power 7. Okay, no sorry, we will not here, sorry my mistake. So what we have to calculate, 2 ki power 14. So power of 2 ki power 14. By mistaken, sorry. We have to multiply a into a, not the this thing. So at the end we have to return the rest. Okay, so initially the result is 1. So as you can see, b is greater than 0, b is 14. So what we will do? Here it is our a. So we will multiply a into a. So what will the a will become? A will become 4. Because a will become now 4. So now go to table here. A, B and result. Result is 1. Currently it is 2 and it is 14. So now A will become 4 in next step and B will become 7 and result is 1. While B is greater than 0, B is greater than 0. So what we will do? We will, and B is now odd. So what we will do? We will 1 minute. So we are here. So what we do? So here, as you can see, base odd. So what will we do? Do result into a. So now result will become 4, and what, and a will become 8. A will become 16. Sorry, because 4 into 4 equals to 16, and it will become 3. As we will divide the b at every step. So in next step, as you can see, it is greater than 0 and it is odd. So what we will do? We will do result into a. So it will become 4 into 16 and it is 64, and we will divide this by 2, so it will become 1, and it is become 16 into 16, and 16 into 16 is 2 16 into 16. Let's use a calculator. Okay, 16 into 16 is, yeah, this, I don't remember squares also, so math, it is 256. Okay, and now it is 1, it is 256. Now as you can see, b is 1 and it is greater than 0, and it is odd. So what we will do? We will do 64 result into 64 into 256. Okay, 256, and we will divide this by 0, and what it will become? 256 into 256, as it is greater than 0. Sorry, it is, as it is 0, it is not greater than 1, so not greater than 0. So we'll break the loop and we will return the answer, which is 64 into 256. 64 into 256. Okay, so it is indeed the, let's again check it on calculator. It is working fine. 64 into 256, it is 16384 that we have got in the recursive approach, and it is indeed the answer. So how many steps, as you can see, we have taken in this? 1 step, 2 step, 3 step, 4 step, and 5 step. In 5 steps, we can calculate the answer. So it is the basic funda of the binary exponentiation. So let's again code here. So it will return on this, and let's say iterative binary exponentiation. Again expo. So it will take this. So here we will declare is equal to 1. As you can see, if while n is greater than 0, so if n not 2 equal 1, so what we are going to do, rest into equal a, and a into equal a every time, and b divided equal to 2, and we return the rest here. So so as you may have doubt that if this condition is never be satisfied, or and will never become odd, then the rest will become 1. So as you can see, at the end, rest will, sorry, n have to become 1. So at the end, rest will have to become 1, so we will get the correct answer. So for example, let's take another example. Oh, what it is, what is given, wrong answer. Okay, here, even to equally. It will give the correct answer. So for example, let's take another example. 2 to the power 16, let's take. So as a and b, this is 1, a is 2 and b is 16. So b is odd, so b is even and greater than 0, so we will write this. This will become 4, e will become 4, this will become 1, so it is greater than 0, and it is even, so it will become 4, it will become 4 into 4 16, it is 1, it is 2, that is 16 into 16 is 256, it will become 1. Then at that it have to become 1. So it will become 256 into 256, and it will become, and what it will become? It will become 1 to 256. 256. Okay, and we will return the rest. So that is indeed the answer. 2 to the power 16 equal to 256. No, yeah. No, not 256. Sorry. It will become 256 into 256, not 256. So it is indeed the answer. 2 to the power 8 into. So at the end, any number, when you are continuously dividing it by 2, it will eventually become 1. And so it will give the correct answer, because if n not 2 equal 1. So it will eventually become 1. So it is the basic funda of binary exponentiation. Tomorrow we will see some of the basic applications of it, like large exponent modulo a number. In many questions you have seen like this, you have to calculate a to power b mod something mod m. So we will learn how to, we will see what is modular arithmetic is, and we will learn this binary exponentiation application. Then we will see the effective computation of Fibonacci numbers. As you all know that Fibonacci numbers are calculated in of n time, but it can be calculated in O log n time using this technique. And then we will see applying permutation k times on a array. We'll see these many questions here in this topic, binary exponentiations application. Okay. So if you have any doubt, you can post it in the comment section for today. And if you want me to make video on any another topic, so let's post it in the comment section too. And thank you guys, and happy learning.